Frame of reference in relative motion. The frame of reference is the object that we pretend is completely still. Why do we need a frame of reference? Without a frame of reference, there is no way to know how to answer a question about motion. Imagine you were trying to determine how fast a dog was moving. If the dog was moving at 5 meters per second, would you also include the speed of the Earth rotating at 416 meters per second? Or the speed Earth moves around the Sun at 30,000 meters per second? Or the solar system moving at 20,000 meters per second? Or the galaxy moving at 230,000 meters per second? This is why we need a frame of reference. Normally, we pretend that the Earth is still and we are looking at the motion in relation to the Earth. So an object is in motion if its position changes compared to the point of reference. So look at the dragonflies below. Determine the velocity of each dragonfly and the flower based on the flower's frame of reference. So the flower is at 0 meters per second. So the blue dragonfly would be moving at 2 meters per second east, while the pink one is moving at 1.4 meters per second west. Now determine the velocity of each dragonfly and the flower based on the pink dragonfly's frame of reference. So now we're going to say that the pink dragonfly is moving at 0 meters per second. That means that the flower is moving towards the pink dragonfly at 1.4 meters per second east. And the blue dragonfly is moving at 3.4 meters per second east. Now, determine the velocity of each dragonfly and the flower based on the blue dragonfly's frame of reference. So this time, we're pretending like the blue dragonfly is what's still. So the flower is now moving towards the west at 2 meters per second, and the pink dragonfly is moving at 3.4 meters per second west.